Welcome back to part 3 of Models for Logistic Growth. Example 3 says, assume that the carrying capacity for the US population is 800 million. Part A says use the carrying capacity and the fact that the population was 282 million in 2000 to formulate a logistic model for the US population. So for part A, let T be defined to be the number of years after the year 2000. And so T equaling 0 would correspond to the year 2000. And we want to figure out capital A from our formula. And we know that capital A is equal to the carrying capacity minus the initial population over the initial population. We are told that the carrying capacity is 800 million. So to make our life easier, why don't we have our population function measure the population in millions of people? So then my carrying capacity would be 800. And my initial population in 2000, we can say 282. And if you simplify that, we get 259 over 141. So then our population function that's going to model the population of the US will be, the general formula was m, the carrying capacity, over 1 plus a times e to the negative kt. Here our carrying capacity is 800. And we just found our a value to be 259 over 141 times e to the negative kt. So that's our answer for part A. Part B says determine the value of k in your model by using the fact that the population was 309 million in the year 2010. So in 2010, that is t equaling 10. So that's basically telling us that p of 10 is equal to 309. So let's go ahead and plug that in for t. So we'd have 800 over 1 plus 259 over 141 e to the negative 10k. So all we did was we replaced t with 10, and then this is equal to 309. So what we want to do is we want to solve this equation for k. So I'm going to, like we did previously, I'll take the reciprocal of both sides. So I get 1 plus 259 over 141 e to the negative 10k power. Then that would be over 800. And then the reciprocal of the other side would be this. I'm going to now go ahead and multiply both sides by 800. So we get this. And then from here, I can subtract both sides by 1. Then from here, I'm going to multiply both sides by the reciprocal of 259 over 141. So we get e to the negative 10k is equal to, I'm going to go ahead and simplify that fraction. So on my calculator, I'm getting 23077 over 26 677. From here, I can take the natural log of both sides and then divide by -10. So I'm running out of space on my screen. Let's clean this up. Okay, so if I take the natural log of both sides, I get -10k is equal to the natural log of this lovely fraction. And then finally we get k equals -1/10, natural log of that number. All right, so here's our k value, and that's our answer for part B. Part C says use your model to predict the US population in the years 2100 and 2200. All right, so in 2100, our t value would be 100, so we're essentially taking our population function or model and we're plugging in 100. So that's going to be 800 over 1 plus 259 over 141 e to the -100 times k, where k is equal to this lovely thing. And so essentially, we just want to see, can you plug this into your calculator? And if you throw that into your calculator with the highlighted k value, this should be about 559 million people. And then the second part, if we're looking for the population in the year 2200, that's 200 years after 2000, so we're doing essentially the same thing. And now our t value is 200, so this would be -200 times k. And if you threw that into your calculator, this is approximately 727 million people. And the last part, part D, says use your model to predict when the US population will exceed 500 million. So in the year 2100, in part C, we found that the population was 559 million. So using some logic, we could probably deduce that it's going to be sometime before the year 2100. So in part D, essentially what we're doing is we want to solve the equation for t when we set the population to 500, or another way you could think about it is when will the population exceed 500, so you can put an inequality symbol. Either way, when you solve it, this implies that if you solve for t, that the US population will exceed 500 million people after about 77.18 years, or in the year 2077. So that includes example 3.